All right, so acids and bases can vary in strength. For example, if you drink some hydrochloric acid, you're going to severely hurt yourself. But if you drink orange juice, you're drinking citric acid, right? And that's not really that big of a deal. And so we use different tools to measure how strong an acid is. One of the things that tells you how strong an acid is the Ka, and that's the acid dissociation constant. So how this goes is that you have some kind of generic acid, and then it's going to dissociate into H plus A minus, right? It's going to give up that proton. And then we can write an equilibrium constant from it, where it's products over reactants. So H plus times A minus, those are the products, over HA, that's the reactant. And so here you can see that this H plus is on top. And so the bigger the K, the more H plus. And the bit more H plus, the stronger the acid, right? So bigger Ka equals a stronger acid. However, nobody really talks in terms of Kas, right? These numbers are something like 1.2 times 10 to the negative 4, 1.3 times 10 to the negative 8, things like that. That's a mouthful to say. That's a mouthful to say. So instead, what we use is pKa instead, and it means the same thing. It's just a quicker, more efficient way of saying it. So this means the negative log of the Ka. So you literally just take your Ka, plug in your calculator, negative log it, right? So your pKa, again, is the negative log of the Ka. And then if you want to reverse it, right, a lot of people do the kind of the math wrong here. It's 10 to the negative pKa is equal to the Ka. And so if you have a pKa of 10, that means your Ka is 1 times 10 to the negative 10. And so they're actually inversely proportional. A lower pKa is equal to a stronger acid. And in this course, we're only going to talk about pKas. So don't even worry about Kas. We're strictly sticking with pKas. The other thing I want you to know about pKa is that the scale is logarithmic. And so what this means is if we have acid 1 and it has a pKa of 1, and then we have acid 2 with a pKa is equal to 4. First of all, we can identify which one is the stronger acid, right? Lower pKa means stronger acid. So this one on the left is the stronger acid. And not only do we know it's the stronger acid, we can tell how much stronger the acid is. So all you do is you subtract these numbers. So 4 minus 1 is equal to 3, and it's a logarithmic scale. So 10 to the third is 1,000 times, right? So acid 1 is 1,000 times stronger than acid 2, right? So I want you to know that lower pKa is stronger and that it's a logarithmic scale. And so the most often used here is these pKa charts. And these are pretty important to know for organic chemistry. I won't make you memorize them simply because you can just look them up, right? But it is good knowledge to know. And so you can see here, sulfuric acid, H2SO4, has a pKa of -9. You can have pKas of negative. That's totally fine. And it's a strong acid, right? It's the strongest acid. Whereas this ethane molecule, right, this CH bond has a pKa of 50, and that's a very weak acid, right? So again, just low pKa, stronger acid.